Hello and welcome to Discrete Math for Computer Scientists. This is lecture 2 of our series of lectures. Today's lesson is on Introduction to Counting. What is combinatorics? So combinatorics is an area of math that's concerned with arrangement of objects into patterns under certain constraints. And what we care about today is counting, a sect of combinatorics, which is concerned with the number of ways we can obtain arrangements of distinct objects. So we're going to start today by thinking about this theorem. If m and n are integers and m is less than or equal to n, there are n minus m plus 1 integers from m to n inclusive. What inclusive means is it's including m and n, the boundaries. So how can we use this to solve this first problem? How many 3-digit integers are divisible by 5? So the easiest way to do this is we can check and see that the first number that's divisible by 5, that's 3 digits, is 100. And 100 translates to 20 times 5. The last integer that's 3 digits long that's divisible by 5 is 995. What that is, it's 199 times 5. So now what we can do is check how many numbers are between 20 and 199. And we can see here that the math is simple. 199 minus 20 plus 1 equals 180. And that's your answer right there. Something else we can do is use a tree diagram. And what that is it's a helpful tool to keep track of outcomes of a combinatorial process. We can use that for problem number 2 here. So teams A and B play each other in a best of 3 match. What that means is they play until one team wins 2 games in a row or 3 games are played total. So questions are, how many outcomes are there, and what if they always play 3 games total? We can use these tree diagrams here to decide this. So part 1 we'll look at. Part 1, we could start with single node, branches off into here. This is the outcome where A wins, and here the outcome where B wins. Next, we have another outcome where A wins again, and here we could see this is a final node of the map because best of 3, this team A won 2, and here B wins. Down below, the outcome where B wins is also a final node, and the outcome where A wins down here is not a final node. So these also have outcomes of A and B as well. In this outcome, A wins, and this outcome B wins. Same here. In this outcome, A wins, and in this B wins. So when we count the number of green boxes here, we can see the total number is 6 outcomes. Let's add a page. So for part 2, where they always play 3 games total, the map looks more like this. A and B, then again A and B, finally again A and B. Here A wins all 3, here A wins, then A wins again, B wins. Here we have another set, A, B, and we repeat the same below, but we can see that this should be the same count on the bottom side. So 1, 2, 3, 4. 4 times 2 equals 8. So the answer here is 8 total. So these are a couple simple techniques we use for counting. Next we'll talk more about the multiplication rule, which will give us a more advanced method for counting. Thanks.